In this slide deck, I'm going to talk about normalization. I'm just going to try to simplify normalization. I've got some other slide decks that get into some detail and cover it in different ways because different textbooks talk about normalization in different ways. But this is my take on normalization. I tried to simplify it, try to make it as simple as I can, right? So we talk about these three normal forms, right? So we have the first normal form, the second normal form, the third normal form. There are other normal forms that textbooks will talk about, like Boyce-Codd, and the fourth and the fifth normal form. I'm not going to address those directly because in the real world, most of us go to third normal form, and we don't really even think about Boyce-Codd or third and fifth, and or fourth and fifth rather. And in the reality is, in many cases, when we get to third normal form, we're already at the other normalized forms anyway. We don't have to go through the exercise to get there. And I'm going to talk about denormalization here too. So I found in many cases, if we try to over normalize, we end up stepping back anyway. In some cases, we have to step all the way back to second normal form. So what's the point of going, that deep? But again, it's one of those things that somebody's probably going to leave a comment in my video saying, Brian, you're wrong. You should always go to fifth normal form. And you can certainly make your case, but the reality most of us live in is we don't really think about anything past third normal form. We don't validate that we're at the fifth normal form. So what is the first normal form? To get the first normal form, we're going to try to eliminate repeating groups. So these are lists of values or enumerated fields. And then each field should be a single data type, and that's it. And then once we get there, then with the second normal form, we're going to remove functional dependencies, what is a functional dependency? It's groups of columns that depend on each other rather than the primary key, right? So it's a kind of, some people call it a partial dependency, right? A partial dependency where it's a group of columns that are dependent on one of the attributes, but they really don't care about the primary key, right? And then the third normal form is transitive dependency or transient dependencies or transitive dependent, depending on the textbook you're reading. This is where a field depends more on another column rather than the primary key. So it's not as explicit as a functional dependency, right? It's a little softer than a functional dependency. And you're going to see an example of what this looks like. So let me just show you, in the real world, how would I do this? Let's say I've got a table of students, right? So I've got some students in my class and I've got a little spreadsheet, and this is what it looks like. So I've got their name, their phone number, then I have a second phone number, their address, the city, and the state. And this is this is probably more common, right? Is that you'll see somebody create a table or a spreadsheet and they've got multiple values for, say, phone number. They just have, column 1, column 2, column 3 for the 3 different types of phone numbers or the 3 or 4 different email addresses. And then when they get somebody who has 5 email addresses, they just add a bunch of columns to accommodate that and then add those 5 email addresses. Or sometimes you'll see them comma delineated, right? They'll list 4 or 5 different phone numbers in the same column in Microsoft Excel, for example, if you're looking at something that hasn't been turned into a database. So that's the first thing we have to do. We have to try to eliminate those columns that are enumerated values or multiple possible values. So what I usually call that, it's repeating in the horizontal direction, right? So we want to eliminate anything that repeats in the horizontal direction. And instead we convert it so that they're repeating in the vertical direction, right? So we go from repeating horizontally to those fields repeating vertically, right? But the problem we have now is now we start to see where we're going to have these insertion, deletion, and update anomalies, because if I try to update Daniel Mortimer's name, it's I have to update it in multiple places. If I delete certain things, it's for example, if I delete both Dan Mortimer records, I'm sorry, if I delete both of Luke Young's records, then there's no more PA, right? Pennsylvania disappears, right? And so does elsewhere, Pennsylvania. So that we're going to worry about that when we go to second normal form. For right now, once we have these repeating values in the vertical direction, we're at first normal form. So again, from horizontally repeating to vertically repeating, we're now in first normal form. Then once we have these vertical repeating records, we are going to try to resolve that, right? So we're going to add our primary key here. So you can see we have these repeating primary keys, and we're going to try to eliminate that. And one way we do that is by creating a new table for anything that repeats in the vertical direction, right? So all that stuff that's repeating vertically, we create a new table. And that is going to get us hopefully to second normal form. So we're going to use a foreign key, right? So we have a foreign key relationship. We take the ID of the student, and that becomes the foreign key in our phone number table. But then you can see we don't need all the records now in that table, right? So these groups of records are going to collapse, and we only have 3 records now in that table, right? So we've reduced that redundancy, right? So we've eliminated the redundancy for the most part, and we created this other table to resolve those vertically repeating columns. This gets us basically to second normal form. Somebody's going to say in the comments that, Brian, you're wrong. There's still some partial dependencies here, whatever. But again, this is my abbreviated getting to third normal form. If you follow this process, you're still going to get the third normal form. It's just not the formal process that that we do from a textbook. So again, this is going to get us this 2NF. So now what do? Now we look for these transitive dependencies, right? So for example, the address, city, and state is something, these are all hidden transitive dependencies, right? So we could take the address and move it to its own table. And we get rid of it from the other table. We add our foreign key, right? That gets us the third normal form, but we could keep going, right? Because now we have this other table, the address table, but it's also got some repeating values, right? We're back to seeing repeating values in here, like the state, for example, which has repeating values. So maybe we move that to its own table, and add a foreign key to reference that. Maybe the city is also repeating values. Move that to its own table, and so forth. So we could end up at the end of all this, having a whole bunch of tables, right? So you can see here, I've got 1, 2, 3, 4 table, or 4 tables, right? Just to describe my students, right? So one of the tables is their name. The other table is going to be their address, but then the address has foreign keys to the city and the state. That way I don't have repeating values for those. And this would be fully normalized, right? Now we're at a point where there are no transitive dependencies here, right? But there are problems with performance when we do that. So in many cases, you have to denormalize. So with denormalization, we're probably going to end up going back to looking at a database design that looks like this, right? So we'll have in this database design, we've kind of, we kept that address, city, state in that other table because, okay, the city and the state's going to repeat sometimes, but it's not the end of the world, right? Sure, Philadelphia might be in that table 50 times, but whatever. It's we'll deal with it because the alternative is database performance, right? Because we have to do all these joins across all these different tables, which takes time and effort for our database engine. So once we do this, right? Once we have this table structure, then we have to figure out, does this support our relationships, right? So if I show my associations between these relations, right, with these lines, I've talked about this before in my other videos, but generally, whichever side of the relationship has the foreign key is always going to be the many side of the relationship, whereas the other side is going to be the singular side, right? And that works here, right? You can see that in both cases, my student has many phone numbers, and my phone numbers always belong to a single student. And likewise, students have an address, and an address can belong to many students, right? Many different students could have the same address. They could all be living in the same dorm, for example, right? So they have the same physical address in that dorm. And that's it. So that's my basic take on normalization. That's 9 minutes of how to do normalization the easy way. So take it with a grain of salt, but that's one way to look at normalization.